This is a continuation of the topic from the previous video. Same instructions as before. Find the equation of a tangent line to y equals 2x plus 1 over x plus 2 at the point 1, 1. This time I'd like to use as the slope the form of the derivative that involves x and a. So the limit as x approaches a of f of x minus f of a divided by x minus a. And we'll note here that a is equal to 1 for the x coordinate of the point that we're given, and f of a, or f of 1, is also equal to 1 from the y coordinate of the point that we were given. So our slope, which is going to be f prime of 1, is equal to the limit as x approaches 1, see a is 1, of f of x. Well, we don't have anything to write for f of x other than 2x plus 1 over x plus 2, minus f of a, which we said is 1, divided by x minus a, and again a is 1. Now I have here a complex fraction, and so I'm going to multiply numerator and denominator by the little denominator, right, the x plus 2. Some people sometimes look at this and they think, oh, I also need to throw in an x minus 1. That's not true, because the denominator, x minus 1, itself has a denominator of 1. We're only looking for denominators of fractions that you can see here. Now I've done the work of distributing in the numerator, and you can freeze the screen if you want to see what's going on. But look, originally I couldn't plug in x equals 1 in place of x in the denominator, because that would have given me a 0. And in the previous example I said the h will always divide out. In this case, the x minus a will always divide out. And when that does, I'll be able to take a limit. So we're looking now at the limit as x approaches 1. And folks, I know this is tedious. I had to write LIM, LIML. I have to write it every single time I'm writing this expression until I actually take the limit. And for us, what that means is until I actually replace x using a 1. Or another way to think of it, if I'm writing x anywhere in this expression, I've got to write the LIM. Anyway, taking that limit gives me a 1/3. And so my slope is equal to 1/3, and I have the point 1, 1. I'm going to put that into y equals mx plus b. I'll again spare you the details. We see that b is equal to 2/3, and so the equation of our tangent line is y equals 1/3 x plus 2/3. And I encourage you to graph the original equation together with the equation of the tangent line so that you can see what's happening at the point 1, 1 and convince yourself that this actually is the tangent line. Now we have an expression of the form of the limit that we just used for the derivative, and we're asked to come up with the function f and the number a for which this is a derivative. What we're matching this up to is the limit as x approaches a of f of x minus f of a divided by x minus a. From that, I can see that a is equal to 1/4. And from the numerator, f of x, I can see is equal to 1 over x. That's all we're asked to do in this exercise. Next up, we are asked to find f prime of a for f of x equals 4 over 1, the square root of 1 minus x. For that, I'm going to use that f prime of a, there's no a, so our answer is going to have an a in it, but I'm going to use that f prime of a is equal to the limit as h approaches 0 of 4 over the square root of 1 minus the quantity of a plus h minus f of a would be 4 over the square root of 1 minus a all over h. Now remember, we want to be able to substitute 0 in place of h. I can't do that while there's an h in the denominator. I'm expecting that if I do the right things, the h will divide out. I've got a couple of things going on. One of them is that I have a complex fraction. So I want to simplify that. Then I'm still going to have radicals, and so I want to rationalize. And in particular, I want to rationalize the numerator. So we're going to do those one at a time. I just realized my work might be easier to follow if I use different colors. All right, so first, simplify the complex fraction. So I'm going to multiply numerator and denominator by the little denominators. So the square root of 1 minus a minus h, I went ahead and distributed, times the square root of 1 minus a. I'm going to multiply that into the numerator and denominator. And I skipped the work, but you can freeze the screen if you want to look at it more closely. Now I need to rationalize the numerator. Before I get to that, I'm going to go ahead and factor out the 4. That way I don't have to keep writing it. All right, so I'm going to multiply numerator and denominator by the conjugate of the numerator, and notice that what's inside the radicals isn't changing at all. So I'm multiplying numerator and denominator by the square root of 1 minus a plus the square root of 1 minus a minus h. And again, you can freeze this if you want to look at it more closely. What we end up with is a numerator in which 1 is going to subtract out. Minus minus a, that's positive, so a is going to subtract out. And I have a minus minus h. Folks, that h is going to divide out. I'm left with the limit, as h approaches 0, of 4 over this hideous denominator. That denominator, by the way, square root of 1 minus a minus h times the square root of 1 minus a, all that times the quantity of square root of 1 minus a plus square root of 1 minus a minus h. Now, the h factor in the denominator has gone away, so I can now substitute 0 in place of h. When I do, 4 in the numerator, 1 minus a, both inside square roots, hey, that becomes simply 1 minus a. And then I have the square root of 1 minus a plus the square root of 1 minus a. That is 2 times the square root of 1 minus a. This whole thing simplifies, so I'll just say f prime of a is equal to, the 2's divide out, and in the denominator I have 1 minus a to the 3 halves power. That is our derivative.